Okay, so on the second page of your notes, we're graphing. We've got some activities. So if you haven't already, pause the video and practice your graphing on here. I'm going to demonstrate those on the board though with you. So we talked about how to solve a system. You want to graph each line. We have 3 methods for solving a system. We can graph it, and then there's 2 other methods we'll talk about in this section. But to graph, it's just what we just finished doing in 6.6. We graph each line. Then we look for where the 2 equations cross. What point works for both equations will be where they cross. So we carefully graph each line. So I'm working on example 1, x plus 2y equals 4, and I'm finding the point plotting method. I'm putting in some points. For 1, I've got a fraction, so I'm going to plug in 2 for x and do 2 plus 2 times y equals 4, and see if I get a point that's a little kinder, you know. They're all valid points, but some graph a little nicer if you don't have to deal with the fraction. So 2, 1, that's over 2, up 1. All right, so then I connect my dots, and I've graphed the first line. Then I start over, and I graph the second line on the same graph that we got going on here. So the second equation is 2x plus y equals -1. Again, you can point plot or use one of the other methods. Whatever you prefer, you can plug in on the y side or the x side. It's up to you. I'm going to plug in 0 and 1, see how that goes. 0 for x is 2 times 0 plus y equals -1, giving me an answer of y is -1. Then I'm going to plug in 1 for x. 2 times 1 plus what equals -1. Let's see, that's -3. And you can keep going. I always recommend you plot 3 points to check up on yourself, but I'm just going to go with the 2 here to save time. 0, -1, over 1, down 1, 2, 3. Okay. And the lines look like they'll cross. Without the graph paper, though, I'm going to have a little trouble seeing exactly where that point is, but you guys do better at home with your graph paper. But it looks like it crosses somewhere maybe back 3, up 4-ish. Without graph paper, I'm not going to swear to that. But we have other methods. Let's see. Do I know the solution to this system? Hey, if I think it's -3, 4, I can check that out and see if it works. Is -3 plus 2 times 4 equal to 4? Not exactly, so I'm off by a little bit. Is negative, maybe it's -2. -2 plus 2 times 4 equals 4. Oh shoot, I should have had that already worked out for you. I have these other methods to do that I know exactly how to get the answer quickly, so I think I'll go ahead and demonstrate that now to show you how to know exactly what that point is. I'm sort of, and you guys, again, if you have graph paper, you can tell exactly where it is. And if you're using the computer program to do your homework, it's going to draw these lines nicely on that grid, and you're going to be able to see exactly where that point is. You can hover over that point too with your cursor, and it'll tell you up in the corner of the screen exactly what that point is. So you'll have that technology to help you out, but I'm struggling with my board example. So while I've got this up here, the second method we're going to learn, and we'll just do each one, both methods to demonstrate, is called the elimination method. So the elimination method is where we need to eliminate either the x's or the y's when we add these equations together. Sometimes elimination method is referred to as the addition method, the add method, because you want to add your equations together. But you can't add, this one's not set up to where it'll work perfectly because the x's don't add out, neither do the y's. So we're going to have to do some manipulating or some pre-work so that'll happen. So what I could do, there's a couple of options, but I could times this first equation by -2. You're allowed to do that because as long as you do the same thing to all the terms, we're keeping an equivalent equation, just changing its looks. So I'm going to times through by -2 onto equation 1, making it -2x. That'll make that actually -4y, and -2 times 4 is -8. Same equation, we've just doubled it and changed its sign, so it's an equivalent form. But now when I add this second equation in our system, now when I do addition, the x's will add out. You need that to happen for this method to work, either the x's or the y's. I could have done that method. But I chose to work on the x's, making that cancel. -4 and 1y is -3y. Negative 8 and negative 1 is negative 9. Divide both sides by negative 3, and now I know the y value, it crosses up at positive 3. It's good to know now. Y is 3. So what is x? You need the x and the y. So this tells me the y value is 3, and that's good enough. I can plug that into any of these former equations and figure out x now. So I'm going to choose this second equation, and I'm going to plug in, now that the known value is y is 3, I can figure out x. 2x plus y is known to be 3 now, and then solve that. Minus 3, 2x equals negative 1, and negative 3 is negative 4. Dividing by 2, x equals negative 2. So the point of intersection for these graphs should have been at negative 2, 3. And it kind of looks like it. Like I said, I didn't graph greatly here without the perfect graph paper, but it's in the ballpark. Back 2 and up 3 should be the intersection. Also, I know that's right if I can check it. Is negative 2 plus 2 times 3 equal to 4? And yes, now it works. It also has to work here. 2 times negative 2, that's negative 4, plus y is 3. Negative 4 plus 3 is negative 1. It works. So that's the second method, is elimination. All right, on to the next one. And like I said, you've got 6 on this paper, so please do pause the video and now see if you can move ahead of me. Practice if you haven't already. All right, number 2. I'm having marker issues today, y'all can see. All right, x plus, or x minus 2y equals 4, and 2x minus 4y equals 8. So for the graphing method, and this is just good for us to practice our graphing, make sure we're good with that. If you don't need that extra practice, then you can just watch the part where I use elimination. But the graphing method, you can either point plot, maybe plug in 0 and 1 for x. You can also plug in on the y side, it's up to you. I think I'll do that. I'll plug in 0 for x and 0 for y, and do it by the intercept method. When I plug in 0 for x, then I can solve for y and get negative 2. So there's one of my points to plot. Now I'll plug in 0 on the y side to find the x-intercept. Negative 2 times y is 0, just zeroes that out and leaves x equals 4. So again, another point. Now, you know we always recommend that you plot at least 3 points before you graph, but to save a little time here, I'm just doing 2. If you're real confident you haven't made a little error in your math, which we should never be too overconfident there, we should always check, but I'm going to do the 2. So 2 points does determine a line, so then connecting your dots draws that first line out. Then I'm going to do the other line, the second one. Oh, and by the way, 2x minus 4y equals 8. Why not divide all that by 2? Oh, you know what happens when you divide all that by 2? It will be exactly what's above it. They're the same line. But I wasn't focusing on that yet to realize it. But do you see that is true? These two are equivalent equations. So when I graph this, it should graph right on top of that. So anyway, pretending I don't know that, I would do my intercept methods maybe. Plugging in 0 for x gives me negative 4y equals 8. And I get, oh, y equals negative 2 again. Then I plug in 0 for y to find the x-intercept. Solving that, you get the same thing, 4, 4, 0. So when I plot those points, 0, negative 2, 4, 0, I'm like, oh, wow, that's just exactly the same line, a line on top of a line. So back from our first page notes, we learned that that means there's infinite solutions. The solution is where these lines cross, and if they're lined on top of each other, they're crossing all over the place, right? Every point is shared point. So there's infinite solutions. Sometimes seen as negative infinity to positive infinity. So every number on the number line, any point that solves for one, there's infinite solutions there. All right, now how would that look if I did it with the elimination method? So we're going to do both methods as we go through this to demonstrate the elimination method or addition methods. I want these to add so that either the x's cancel or the y's cancel. As it sits now, nothing cancels, but if I were to times, say, this top equation by a -2, -2 times x would make these opposites. So I'll have to distribute it by every term, and that's equivalent to this. Now adding it to that second equation, I was only trying to get the x's to cancel, but notice it all cancels. The x's, the y's, the number, so you just have a big O 0 on the left and a big O 0 on the right, 0 equals 0. That's what it looks like when they were the same line. So if you get a 0 equals 0 algebraically, that means there's infinite solutions because they were the same line on top of a line. All right, moving on to number 3. Number 3, we're going to graph these two lines and then we're going to use the elimination method to verify. Alright, so to graph, you can use one of our methods. You know, we talked about how some of you all like to point plot. But you know, I think I'm going to use the other method here to demonstrate solving for y. I'm going to throw the x across the line, making it -3y. This moves over to -2x and bring down the +6. Divided by -3 on each side. So to solve it for y and get it in slope-intercept form, we have a negative over a negative, making it a +2/3 x, and a 6 divided by -3 is -2. So this will be graphable by the slope-intercept method. All right. That's a dry erase. Okay, still have marker drills. All right, so the y-intercept is at -2, so that's the starting point. And then this is the rise over run. From that point, rise and run. They're both positive. I could have left them both negative, by the way. It would have been the same result. But I think it's easier with the negatives canceled out. But that would be rise 2, run 3. Connect your dots. Okay? Graph the other line, 2x minus 5y equals 10. Again, I want to demonstrate this slope-intercept method, but you do the method you prefer. I throw the x term across the line. You always get to get y on one side alone. Solve for the y variable. So we have to divide out this -5 to make +1y. What we do to one side, we do to the other side. The negative becomes +2/5 x, and 10 divided by -5, watch your signs, that's -2. So slope-intercept, this is where we start, y-intercept of -2, and then rise and run, +2, +5. So up 2, 1, 2, 3, 4, 5, over 5. And then connecting those dots, we can see these lines actually crossed at the point 0, -2. That was a point they actually had in common. They had the same y-intercept. So that is going to be their crossing point. But that's demonstrating with the graphing method. Now I'll do that with the addition method. Have I got time? Yeah. So if I were going to add these two together, right now nothing cancels. But if I changed all of these to the opposite sign, which you're allowed to do, or I could have done it down here, but times through by a -1, which switch the signs, then the x's cancel. 3 minus 5 is -2. -6 plus 10 is 4. Divide both sides by -2, and y equals 4 divided by -2 is -2. We know that is where it crosses. Y is -2. What about x? What does x equal? Then we plug in y is -2 into any of the former equations, guys. It doesn't matter where you go with that to get x. They're all equivalent equations, equivalent forms of it. So say I take this form, I plug in y is -2. I get -2x minus 6 equals -6. Throw the -6 across. Divide by -2. 0 divided by anything is 0. There's my point. 0 for x, -2 for y. The same thing we got with the graphing method.